Hi, I'm Phil Morrison from Driftworks, and this is my LP640 project. You can probably see there's a new addition, a massive new addition to it, but we'll get to that in a minute. First, we've got the proper CNC'd parts back from Martin, our machinist friend, for the drop knuckles, so we'll take a look at them first. So what the hell's going on? This is covered by the 9 preceding episodes, but if you've not watched them, I'll just bring you up to speed quickly. I own a Murcielago, an LP640. I'd gone as far as I could with it as a road car. I've always loved the Writer Engineering R-GT race cars, particularly the GT1 version, the LeMans version. So I decided to buy some body panels, the original body panels off an GT1 car, the one that drove in the 2008 Le Mans race. This kit's designed for a race car. The race car runs about 120 mil lower than the road car. So basically, to make it work with my road car, we have to make the front suspension work more like the race car, which is extremely complicated and has loads of effect on other things like the doors. The hinges have to be removed for the doors, and we had to refabricate all that sort of stuff. But one of the most complicated parts was making sure the suspension still worked after it's lowered. So that's where the huge geometry change comes in, the drop knuckle fabrication that we're doing here. So this all started with basically working out the drop that we needed to actually change this mounting position point here, this mounting position point here, and the drop that we would need is there for the tie rod end is basically the same as that. And then I had to go to Martin's and kind of translate the drawings that I'd made, my very crude drawings. Martin's toy box. This is Martin.
Hello.
So, what machines have we got in here?
I've got 3-axis CNC Miller,
yeah.
4th-axis Nikon, got a Haas SL20 lathe, and then various manual bits of kit, and the CMM.
What's a CMM2?
Computer controlled measuring.
Ah, okay, that's what. Ah, yeah.
Basically.
Oh, and it just so happens to have. So then, the small matter of 3 weeks of work later. So yeah, this is HE30, and the insert that's been made here, that Martin's made for us, is
EN18,
EN16, I think.
16, yeah. If I was aware, it's a type of tool steel, I think.
Right.
Martin's more the, metallurgist, what he knows what to use.
Yeah, so yeah, that's a nice little touch, isn't it? He's just put something in there so we can use a C spanner to spin this in. It's a left-hand thread, just using the original. This is where an original steel insert was. The ball joint sat sort of here, and the taper pulled up into here. So this basically extends it with the aluminium, with the steel insert inside it there. We've got the big, this is the lower arm, so we've got a big M22 rod end going on there, and that's made really nicely. And then this is going to have a bolt all the way through it, which we've got to source and machine down, so we've got like nice clearance for the correct articulation on the rod end here as well.
Just confirm people that this will be braced to this point at some point.
Yeah, absolutely.
Just to be sure that we are going to.
Yeah, so that basically gets wound in all the way there. This will be welded here all the way around, and then basically there's going to be a piece of webbing here, which we're probably going to use like 6mm aluminium. We're going to fillet that there with a piece of webbing. We're going to do the same thing from here to here, and then on that side we're going to do. So the other direction, basically, it's going to have a bit of triangulation in the form of webbing there as well.
And this front one here is, you can see Martin's put 2 dowel points in it.
Yeah. So this was the most difficult part for us for him to make. So it took quite a bit for me to explain, because the original tie rod, which is a normal ball joint type, it sits like that here, and what I wanted to do so that I can adjust bump steer if I need to is rotate it 90 degrees so it actually is on that plane instead. But to get this with the correct Ackerman offset, but in line with the top and bottom ball joints
and the correct drop
and the correct drop, real challenge. Martin's absolutely knocked it out, and you can see here just the fine details of this metal insert, the steel insert that goes inside the aluminium. He got a bit carried away, I think, and
he didn't want it to break through.
No, absolutely, it's really nice. And so that is now bolted from this side and pinned, so it literally cannot move. It's going to stay in the correct orientation when it's welded, and that then allows me to correct any minor change in bump steer that we need to correct.
So the
top piece.
One of the originally, if you can remember, this is a screw, and the original top wishbone sat up here.
Yeah.
But the correct way we did it
kind of sat here. If you imagine a normal ball joint, it sat on top of the knuckle here.
So basically, that screws into there. That's a top hat washer that loads up against the aluminium. So when that goes on, that loads up there, which then tightens it, so we're not reliant on the thread really to hold it or anything.
Yeah.
We then have rose joint to go on there like that.
And then
one of the side effects of this was the ABS ring sat. Basically, you have the show the hub and everything bolts in here, and that was the CV for obviously 4-wheel drive originally. So that sat there, and this sat on a cup around it. So that sat there like that, which obviously limits what we can do.
Yeah, when the pin's here, I mean that clearance was okay because we're just having there's a bolt coming up through there and there's a nut on the end of it and a washer, that's fine. But this, it came right into it.
You can see where the sensor sat there, so it sat sort of like that.
Yeah. So Craig's come up with an idea. Well, it was a bit of a challenge, I think, wasn't it? Because 40 tooth, did you say?
Yeah, and this face here isn't level to here, so we need to move it in. Having worked with ABS rings in the past, there's lots of different types of teeth. There's window type, and this is a 40 tooth, which is a bit odd. But after a lot of researching, I found that.
So you need a weenie one,
which is a Chevrolet Matiz or some weird. I think it's a Daewoo part.
You just can't help yourself putting Chevy parts on my Lamborghini. So
effectively, that was the CV.
Yeah.
In this bolts through the hub, and then so that spline effectively bolts all the wheel bearing together and holds everything tight. So that has to stay. Yeah. So that's machined down. So I've left it a bit big at the moment. Just I wanted to double check these. So effectively, that's going to go onto there. So that will sit into the bearing in there, and then that ring will sit in here. It will sit up a little bit higher than that. It sits about there.
Yeah.
And then we can get the ABS sensor, which is, and instead of it coming through here, there is an option for us to actually sit it physically inside.
We hope.
And I think it's going to be tight, but that's so we'll bore a hole for that to sort of sit through, and then we can sit that in and actually sit that on the inside.
Yeah.
And that should work. And
so that's the plan. So what we're going to do before we get too carried away with this is we're going to basically throw the knuckles back on to the car and double check that everything's as it should be. It looks all correct, all the measurements, and from my drawing and everything looks correct. But yeah, we just want to check one more time on the car before we start throwing a load of weld and finalising stuff like this. So I'm just taking this over to the bench to take the spring off quickly. And I remember to put that through the... Oh, you'll be glad.
That goes into there. Should be hub.
So what we're doing here is kind of a final mock-up basically before we commit to welding these parts in place, these fancy aluminium parts. We just want to put the wheel on one more time, check that the suspension works as it should do, and also finish off the suspension arms themselves. So we've done like the basic triangle basically of the upper and lower arms, but what we need to do is we're going to add a bit more strength in here, possibly a little bit up the top as well, but the main thing is the bracket for the damper, for the mounting point here,
and the anti-roll bar.
Yeah, and the anti-roll bar. So what I've done is remove the spring from the damper, because one of the other things we need to do is make sure that when we're making this bracket on the lower arm, that we're getting the bump stop, which you can just see here, to work in the right place. So what we're going to do is a simulated full bump, basically full compression on this damper, jack the wheel up where we need it to be just before it hits anything up here, and then put the bump stop in the correct place and weld the bracket for the lower mount on the damper, hopefully.
Yeah, the fancy little Lamborghini stab links.
Another nice bit from Lamborghini.
Actually, like a little forged aluminium dog band, which is really nice.
Yeah.
I dread to think how much they are. Won't lose that.
Well, I think we can all imagine what's going to happen if one of them wears out.
Yeah.
We're going to be making our own.
So, well, that looks like that's going to work height-wise, so that's good. So, wheel on and up to bump height.
Yeah, please.
Is the plan. Okay, so we're going to allow for the actual, although we hit the bump stop, we're going to allow for the actual bump stop to compress, haven't we? So
yeah, so we're kind of at max height here. Like if we were turned, the wheel would basically hit the door. So we're going to go for a worst case, kind of like a little bit of steering lock. So I can probably go, I don't know, maybe a tiny bit higher for the simulated bit. But what it's showing to us already is that we're going to need quite a big bracket, because basically this needs to be, we need to get rid of this. This damper needs to be compressed all the way up here to have the bump stop in play. So we need to bring this mounting point all the way up to here, really. So, onto a gigantic wang! Craig's had some fun with this. Yeah.
This was actually probably one of the easiest things we've done. It was like, no, not quite sure I can do it, but it sort of come out quite easy. Well, relatively easy, really.
Yeah, bring the ramp down, I guess, and we'll take a look. So this is a bit difficult for us to get exactly right at this stage, because we're having I'm having a deck lid made by Fibre Factory by my friend Richard Grindrod, and until we get that, we won't know where exactly these need to sit. All that basically we've gone off so far is lots of pictures of the original car and how it mounted. Because it's so adjustable, there's looks that I really like, and there's looks that I don't like so much. I generally think it looks a lot better when it's sort of low mount and has a bit of angle on it. Where's that one picture that I kept saying it needs to look like this? There's a side-on picture.
That one.
Not that one there. There's one it's angled quite well.
That one.
That's the one.
Yeah.
So yeah, this is the one that I want it to look like. I'm guessing that this is not a massively high-speed track that they're on. I could be wrong, but the angle of that looks really steep compared to a lot of them. But this is basically the look that I wanted, and I've gone for the different end plates to a lot of the sort of older RGT cars as well, which is this one, which I think looks correct.
Considering it's a ridiculously massive wing, it doesn't look out of place. I mean, I'm not a big wing person at all, but it's actually,
it kind of,
it works.
It was a sort of late decision to go with the wing, and it was after I got carried away with everything else, and I just figured that it would, you know, it would finish the look a little bit. This is still not a replica that I'm going for. I probably need to be clear on that. It's not a replica, it's a road car that's kind of inspired by the GT1 look. So, you know, I wasn't 100% sure whether I was going to like it, but I do at the moment. I think it looks absolutely brilliant.
Is this going body colour as well?
Carbon, hopefully, is the
okay.
plan. I mean, that's up to Gaz though, because I can't imagine getting this much paint off is going to be a lot of fun. No. But yeah, anyway, onto your mounts and brackets that you've made.
Basically, you had these with it. These are the original right gird.
Yeah, these are from Writer Engineering. They're really nicely made, but they're made to basically bolt onto the race car rear frame, which is not what
this
we've
would all
got
be
here.
completely different to this. So
yeah,
rather than cutting these up, what we did, we made a template. This is just like 8mm nylon.
Yeah, it's what we used on the E30 M3 under tray. Just the it's just like a bit of nice plastic, 8mm plastic, basically.
But so I've basically replicated that to that, so that is basically up to here.
Yeah.
So that it mounts, because we've got the rear end of the chassis here. What I did, I made, that's the template. Basically, I had some laser cut tabs made and seam welded and put a welded them onto the back of the chassis to actually spread the load onto the strong part of the car.
Yeah, because this is kind of a supporting structure for things like rear lights, the exhaust mounts, the back parts of the massive silencer that's underneath mount onto this. So we couldn't get rid of it, and we couldn't really move it out of the way.
And it is actually the rear of the chassis. Technically, you know, it is part of the chassis. Well, you know, this isn't a bolt-in section; it is welded in.
Yeah.
So we made some adjustable mounts here. Probably don't actually need to be that adjustable, but it just gives us the option if when we do it, if these don't quite work, then we've got somewhere, and then, you know, it just gives us more choice if we need it.
So yeah, once we've got this carbon fibre one-piece deck lid piece here, we need to get the adjustment right, so how much it pokes out that way, how much it pokes upwards, but also the angle of this is extremely important to get the look correct. I mean, it doesn't look far away here, it looks pretty damn good, but yeah, we just wanted to leave ourselves enough adjustability here, and these plastic pieces, obviously, even though they're properly solid, I mean,
it's literally
you move the car with it. These are obviously still just templates, just for the mock-up, and then once we know exactly what size, what the proportions of this are going to be, then we'll basically get that chopped up and make it permanent. But yeah, it looks superb. So that's about it for this episode. I've actually filmed a load more, but I'm going to do it in another episode. I hope you enjoyed. Give us a like if you did. Make sure you're subscribed. Check us out on all our social media channels at Driftworks, and my own personal Instagram is Phil Morrison DW, where a lot of this stuff is released before it ends up in a YouTube video. So yeah, thanks for watching, and we'll see you next time.
At Driftworks, we've helped over 50,000 happy customers since 2004. Our huge online parts store is simple to use, with superb shipping rates to anywhere in the world, and finance options available for UK customers. We live and breathe wheel fitment, so if you have any questions about your own car or any of our products before placing an order, please drop us an email at shop@driftworks.com or give us a call. Thanks for watching.